Welcome to the next tutorial on current electricity. In this tutorial, I will be discussing the solutions to the problems. These problems I discussed in my earlier tutorial. So here I will be discussing the solutions. The first problem, which of the following resistor arrangements A or B has the lower combined resistance? The first one is a series of two resistances of 10 ohm and 5 ohm. So let us see what you get out of here. So the first one, that is case A, where I have two resistances of 10 ohm and 5 ohm, 10 and 5 ohm, and the connection is in series. Then the resultant or net resistance or combined resistance, whatever you call it, if that be R, then R equal to algebraic sum of the individual resistances, that is R equal to 10 plus 5, which is equal to 15 ohms. So that is the net resistance. In the case of B, we have two resistances, one is 10 ohm and another is 1000 ohm, and they are connected in parallel. Now in case of parallel resistance, if the net resistance be R, if R be net resistance, remember this is not equal to, if net resistance be R, then we can get an equation like 1 by R equal to 1 by 10 plus 1 by 1000, that is the reciprocal of net resistance equal to sum of reciprocals of individual resistances. So in the numerator we get 101, in the denominator we get 1000. So let me strike out R, it will be confusing. Therefore R equal to 1000 upon 101, which is coming close to, I think, 9.9 or 9.8 or 9 point some. Let us find out what it comes. 1000 upon 101, which will come to 9.9 equal to 9.9 ohms. So let us write the result here. In the first case, the net resistance is 15 ohms. In the second case, the net resistance is coming to 9.9 ohms. Okay, a wire that has resistance R is cut into two pieces. The two parts are joined in parallel. What is the resistance of the combination? Okay, let me draw a new board. Now here, initially I had a wire which had a resistance of R. Then I cut this wire in the middle. I cut it in the middle, and then I combine these two in a parallel connection. So these are the two pieces now, and I combine them in a parallel connection. So each piece will have a resistance of R by 2, because length has become half. So we know that if the length becomes half, resistance will become half. We studied this law before, because resistance is directly proportional to the length. Therefore each piece will have a resistance of R upon 2, and they are connected in parallel. Now let the net resistance be R. No, not R. Let us say R1, because if I write R, it will be confusing. Therefore 1 by R equal to 1 by R1 equal to 1 by R upon 2, because each resistance is R upon 2, plus 1 by R upon 2. So I think we have to take it up. So now let us continue this here. Therefore 1 upon R1 equal to 2 upon R plus 2 upon R equal to 4 by R. Therefore, R1 equal to R upon 4. Therefore, that net resistance will be 1/4 of the original resistance, 1 by 4 into R. This is the resultant resistance. Okay, I think we have few more problems to solve. So let us see where we are now. Okay, next one. No, not this one. This we have already solved. Actually, I opened all the problems at the same time. Okay, we need to solve this problem. So yeah, this is now let us go to figure 2.1. Okay, first let us write the answer is R upon 4. Now let us go to figure 2.1, that is the next problem. Here, yeah. Now let me pull a new board. Now calculate the combined resistance when two resistances of 500 ohm and 1000 ohm. Let us take the case 1. Calculate the combined resistance in each case. So I have one of 500 ohm and another of 1 kilo ohm, which is 1000 ohm, connected in series. So 500 ohm and 1000 ohm, when connected in series, the resultant resistance will be 500 plus 1000, which is 1500 ohms. Now in the second case, I have two 2 ohm resistances connected in parallel. So if R be the resultant resistance, then 1 by R equal to 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is 1. Therefore, the net resistance here will be 1 ohm. Now the third problem, that is problem number C, it is little bit interesting. Here it is a combined case. First of all, I have two resistances, 4 ohms each, which are in parallel. Two 4 ohm resistance are in parallel. Then this again is connected in series with another 3 ohm resistance. So first I have to find the resultant resistance from this 2 4 ohm resistance. Maybe I will discuss this in the next tutorial because it will become very big otherwise.